Meena and Rita start a small business together. Meena puts in 3,000 rupees and Rita puts in 5,000 rupees. At the end of the year, they earn a profit of 4,800 rupees, and now they must decide how to split it. Splitting the profit equally, 2,400 rupees each, would not be fair, because Rita risked more money than Meena did. The fair way is to split the profit in the very same proportion as the money they put in, 3,000 compared to 5,000. Notice we're comparing rupees to rupees here, the same kind of quantity on both sides. That's what makes it a proper ratio in the first place. Both 3,000 and 5,000 share a common measure of 1,000, so this really shrinks down to a simple split of 3 to 5. Picture the whole profit cut into 8 equal parts in total. 3 of those parts belong to Meena, and 5 of them belong to Rita. To find out what one single part is worth, we take the actual profit and divide it by the total number of parts. 4,800 rupees divided by 8 parts gives 600 rupees for every single part. Meena owns 3 of those parts, so her share is 3 times 600 rupees, which is 1,800 rupees. Rita owns 5 of those parts, so her share is 5 times 600 rupees, which is 3,000 rupees. As a check, 1,800 plus 3,000 comes right back to the full 4,800 rupees, so the split is exactly right. Here's something powerful. 3 to 5 is exactly the same fair split as 300 to 500, or even 30,000 to 50,000. As long as we multiply or divide both sides by the very same number, the fairness of the split never changes at all. That's exactly why we shrink a ratio down to its smallest matching parts first. It's what let us turn 3,000 to 5,000 into a simple 3 to 5. The very same parts idea works just as well with 3 people. Say Meena, Rita, and Sana invest in the ratio 2 to 3 to 5, and this year's profit is 6,000 rupees. First add up the parts. 2 plus 3 plus 5 gives 10 parts in total. 6,000 rupees divided by 10 parts gives 600 rupees for every single part. So Meena gets 2 parts, 1,200 rupees. Rita gets 3 parts, 1,800 rupees, and Sana gets 5 parts, 3,000 rupees. Now picture a paint shop, where 2 different workers each mix their own batch of green paint from blue and yellow. We want to know whether both batches are really the same shade of green. In other words, is 4 to 6 really the same split as 6 to 9? Shrink each ratio to its smallest matching parts and compare them. 4 to 6 shares a common measure of 2, so it shrinks to 2 to 3. 6 to 9 shares a common measure of 3, so it also shrinks down to 2 to 3. Both batches shrink down to the exact same 2 to 3 split, so yes, they really are the same shade, and that matching is what we call 2 ratios being in proportion. Proportion also helps us scale a recipe. Say a cake recipe uses flour and sugar in a ratio of 2 to 3. If we want a bigger cake using 10 cups of flour, how many cups of sugar keep the very same taste? First check how many times bigger our flour amount is. 10 cups divided by the original 2 parts of flour is 5 times bigger. Since every part of the recipe has to scale up by that very same 5 times, the sugar scales up 5 times too. 3 times 5 is 15 cups of sugar. So 10 cups of flour needs 15 cups of sugar to keep the exact same 2 to 3 taste. Every ratio is really just a whole cut into equal parts. Divide the real total by the number of parts to find what one part is worth, then multiply back up for whatever share you need. And 2 ratios are in proportion exactly when they shrink down to the very same smallest split, which is exactly how we double-check a fair split or a scaled-up recipe. 2 friends, Meera and Sanjay, share a box of 45 mangoes and the ratio 4 is to 5. How many mangoes does each friend get? Just like splitting the profit between partners, We cut the total mangoes into equal parts matching the ratio, 4 plus 5 parts, and find what one part is worth. First, we add the parts. 4 plus 5 gives 9 equal parts in total. Now we divide the 45 mangoes by the 9 parts to find what one part is worth. Mira has 4 parts, so we multiply 4 by 5 mangoes, giving her 20 mangoes. Sanjay has 5 parts, so we multiply 5 by 5 mangoes, giving him 25 mangoes. 20 mangoes plus 25 mangoes gives back 45, so our split is correct. A rope of length 72 meters is cut into 2 pieces and the ratio 5 is to 7. Find the length of each piece. The rope is just a hole cut into equal parts, so we find the total number of parts first, then find what one part of rope is worth. 5 plus 7 gives 12 equal parts making up the whole rope. We divide 72 meters by 12 parts to find the length of one part. The first piece has 5 parts, so it is 5 times 6 meters, which is 30 meters. The second piece has 7 parts, so it is 7 times 6 meters, which is 42 meters. A school has students in the ratio of boys to girls as 3 is to 2. If there are 180 boys, how many girls are there, and what is the total number of students? This time, we already know what a group of parts is worth in real students, since we know the boys count, so we can find one part directly instead of dividing a total first. The boys make up 3 equal parts, and together those 3 parts equal 180 students. Dividing 180 by 3 tells us that one part is worth 60 students. Girls make up 2 parts, so we multiply 2 by 60, giving 120 girls. Adding the boys and girls together, 180 plus 120 gives 300 students in total. 3 brothers, Arjun, Burrit, and Chetan, invest money in a shop in the ratio 2 is to 3 is to 5. If the total investment is 6,000 rupees, find each brother's share of investment. This is a 3-way split, just like sharing among 3 people, so we still add up all the parts first and then find what one part is worth. 2 plus 3 plus 5 gives 10 equal parts in total. We divide 6,000 rupees by 10 parts to find what one part is worth. Arjun has 2 parts, so his share is 2 times 600, which is 1,200 rupees. Burrit has 3 parts, so his share is 3 times 600, which is 1,800 rupees. Chetan has 5 parts, so his share is 5 times 600, which is 3,000 rupees. Checking, 1,200 plus 1,800 plus 3,000 gives back 6,000 rupees, so the split is correct. Are the ratios 8 is to 12 and 18 is to 27 in proportion? To check proportion, we shrink each ratio down to its smallest equal parts and see if both ratios land on the exact same smallest split. 8 and 12 can both be shrunk by dividing by 4, giving 2 is to 3. 18 and 27 can both be shrunk by dividing by 9, giving 2 is to 3 as well. Since both ratios shrink down to the exact same smallest split, 2 is to 3, these two ratios are indeed in proportion. Check whether 15 is to 40 and 21 is to 54 are in proportion. Again, we shrink both ratios to their smallest equal parts and compare, but this time we should be careful since the numbers might not match. 15 and 40 can both be shrunk by dividing by 5, giving 3 is to 8. 21 and 54 can both be shrunk by dividing by 3, giving 7 is to 18. 3 is to 8 is not the same smallest split as 7 is to 18, so these two ratios are not in proportion. A recipe uses flour and sugar in the ratio 3 is to 2. If a baker uses 18 cups of flour, how many cups of sugar should be used to keep the same taste? This is the missing quantity problem, like scaling up a recipe. We find how many times bigger the new flour amount is compared to the ratio's flour part, and scale the sugar part by that same amount. The flour part in the ratio is 3, and the baker actually used 18 cups, so we check how many times 3 fits into 18. Since everything is scaled up 6 times, the sugar part, which is 2, must also be scaled up 6 times. So the baker should use 12 cups of sugar to keep the same taste as the original ratio. A map is drawn to scale so that 4 centimeters on the map represents 60 real kilometers. If 2 cities are 150 kilometers apart in real life, how far apart are they on the map? Here the real kilometers side is the known total, so we first find what 1 real kilometer of map ratio is worth, then scale the map centimeters using the same idea as finding 1 part's value. First, let's find what 1 kilometer on the map scale is worth in centimeters by dividing 4 centimeters by 60 kilometers. Instead of using that awkward decimal, it's easier to see how many times bigger 150 kilometers is compared to the 60 kilometers in our ratio. Since the real distance is 2.5 times the ratio's 60 kilometers, the map distance must also be 2.5 times the ratio's 4 centimeters. So the 2 cities should be shown 10 centimeters apart on the map. A sum of money is divided among 3 friends, Priya, Rohan, and Salim, in the ratio 3 is to 4 is to 6. Salim gets 900 rupees more than Priya. Find the total sum of money. Here we don't know the total directly, but we know the real difference between 2 people's shares, so we first find how many parts that difference covers and use that to find the value of 1 part. Salim has 6 parts and Priya has 3 parts, so the difference between them is 6 minus 3, which is 3 parts. We know this difference of 3 parts is actually 900 rupees in real money, so we divide 900 by 3 to find 1 part's value. Now we add up all the parts in the ratio. 3 plus 4 plus 6 gives 13 parts in total. Multiplying 13 parts by 300 rupees per part gives the total sum of money, 3,900 rupees. In a bag of red and blue marbles, the ratio of red to blue is 5 is to 7. After 8 more blue marbles are added, the ratio becomes 5 is to 9. How many red marbles are in the bag? Since the red marbles didn't change, their number of parts stayed at 5 in both ratios, so the change happened only in the blue parts, and that change in parts must match the real 8 marbles added. Blue went from 7 parts to 9 parts, so the increase in parts is 9 minus 7, which is 2 parts. We're told this increase of 2 parts is really 8 marbles, so dividing 8 by 2 tells us 1 part is worth 4 marbles. Red marbles are 5 parts, so we multiply 5 by 4, giving 20 red marbles in the bag. 2 containers hold a mixture of milk and water. Container A has milk and water in the ratio 7 is to 3, and container B has milk and water in the ratio 3 is to 2. If both containers hold 50 liters each, which container has more milk, and by how much? We treat each container separately as its own whole cut into equal parts, find the value of 1 part in each, work out the actual milk in liters for both, and then compare those 2 real amounts. In container A, 7 plus 3 gives 10 equal parts, and 50 liters divided by 10 parts means 1 part is 5 liters. Milk in container A is 7 parts, so 7 times 5 liters gives 35 liters of milk. In container B, 3 plus 2 gives 5 equal parts, and 50 liters divided by 5 parts means 1 part is 10 liters. Milk in container B is 3 parts, so 3 times 10 liters gives 30 liters of milk. Comparing 35 liters to 30 liters, container A has more milk, and it has 5 liters more than container B.